Hello everyone, welcome back to the channel. In today's video, we're diving into day 6 of solving problems in HackerRank. This problem is named grading students. I'll walk you through my solution, my thought process, how I approach every single step of the problem, and hopefully we'll come up with a solution together. Whether you're a fellow beginner or an experienced coder, I hope you'll find something of value in my process. And that's what I'm here for, so stick with me and let's jump into the video. Hope you like it. The problem of today, we just moved from warm-up to implementation. And the first problem of today, we can see that immediately it's going to be a little difficult. It is still in the easy category, but it's going to be a little more verbose, if that makes sense. Because we can see that we have images here, visualization, more examples, more explanation. So let's jump into it. Let's give it a go. Hackerland University has the following grading policy. Every student receives a grade in the inclusive range from 0 to 100. Any grade less than 40 is a failing grade. Sam is a professor at the university and likes to round each student's grade according to these rules. If the difference between the grade and the next multiple of 5 is less than 3, round the grade up to the next multiple of 5. If the value of grade is less than 38, no rounding occurs, as the result will still be a failing grade. So, example number 1, 2, and 3. Number 1 says grade equals 84, round to 85. 85 minus 84 is less than 3. Okay. Grade equals 29, do not round, that's less than 40. 57, do not round, 57 minus 60 minus 57 is 3 or higher. Interesting. Given the initial value of grade for each of Sam's and students, write the code to automate the rounding process. So, given the initial value of grade for each SEMs and students, so from that I can infer we're gonna be working with an array. We'll get there. Complete the function grading students in the editor below. Grading students has the following parameters: integer of grades, the grades before the rounding, return an integer, and the grades after rounding as appropriate. So yeah, we're going to be working with an array of integers. Input format says the first line contains a single integer and the number of students. Okay. Each line I of the n subsequent lines contains a single integer, grades of I. So we're going to have an array of students from 1 to 60. And then we are going to have grades from 0 to 100 for those students. Okay, there's another example here that says the original grade was 73, rounds up to 75, 67, 8 stays the same, 38 goes up to 40, 33 stays the same. Explanation, so the one receives a 33. Okay, I think I caught up on it. Yeah, as explains up there, if the difference towards the next multiple of 5 it's greater than 3, then or 3, because here is 3 and it stays the same. So it's if it's greater or equal to 3, stays the same. 33, 38, yeah, that's 2. So a good thing about multiple of 5s is that all multiple of 5s are always going to end on 5 or 0. So 40, 45, 50, 55. So all those are multiple of 5s, which kind of give us a little, they obviously didn't mention any of that, but that's a little inference there. That could help. Definitely a little more verbose, definitely things that I'm going to have to consider. So it's talking here, it says the difference. So subtraction can be important at some point. The difference between the grade and the next multiple of 5 is less than 3. Okay, so we know we're going to be working with an array of integers. We know that's going to be from 0 to 100. If it's greater than 3, I think this is a good time to maybe jump into the little board. And let's see here what we have. We can say we're going to have an array. We're going to have an array of integers, and each array is going to contain numbers. I'm not trying to make this perfect, obviously, but just to get an idea of how we're going to be working on. So one of the examples was, let's say 67, which is not going to be modified. Then let's say 78, which will be modified. Then let's say 84, because we're looking at the difference between 2 and 3, but 84 is one number away from 85, which is a multiple of 5, right? So there's something here that I think I want to check it out. Okay, if the value of grade is less than 38, no rounding occurs, as the result will still be a failing grade. Okay, so since the value can't be greater than 3, in the case of less than 38, let's say 37, we can't round that up because it's equal to 3, equal or greater than 3. So 38 is, let's say, our lower bound, right? So really we're just going to be analyzing or modifying the grades that are above 38, because 38 plus 2 is 40, which is a multiple of 5, and so on. Anything below, then we can't round up, and then that student is just simply going to fail the test, right? Which, let's hope that's not what happened with me here now. Anyway, so let's go back here, and yeah, so we can say, for instance, we can say 38 here, just for the sake of the example. Let's make that a little smaller. And so that's not going to be modified. That will be modified. That will be modified. That will be modified. And then let's do 37, which won't be modified, right? Basically, we're going to iterate over, I'm going to move this here. We're going to basically iterate over the whole array. It's already established that the array, it's going to be, where it says here, it says that the array is going to be 60 would be the maximum number of the array. So we know that even though if it's going to be O(n) time operation, in case we have to check all the elements, which I believe we do, it's going to be big O of n, but the array, it's going to be always 60, which we can definitely apply some operations on an array of this size without having to worry about the array growing dynamically and this time complexity going up. So that's just a little go over that, just to know that we have some flexibility. So we're gonna go over through the whole array, and basically we're gonna check if the number, so we're gonna check if this number, how far this number is, from the next multiple of 5. We already said that, or I already mentioned that multiples of 5 always end on 0 or 5. Always end on 0 and 5. So make this a little better here. 0 or 5. So we know that that's true for every value. So I'm trying to think how we can operate in these numbers one by one to check that. It's very possible that I'm gonna need to create a new array to, let me do this somewhere else, maybe here, maybe here. Okay, it's very possible that I'm gonna have to make a new array because I can try to apply the conditionals I'm gonna need on top of this array, modified in place, but that might be a little bit out of my comfort zone. It might take me some time. I would have to Google something. So let's say that I'm gonna need a new array for now, where I'm going to pass all the numbers I modify. So 67, with 67 would just stay the same. 78 will round up to 80. 84 will round up to 85. So here we added 2. Here we added 1. Here we didn't add anything. 38 we add 2, and it's equal 40. And this is lower than 38, so we're not going to operate in it, so it passes the same. So the resulting array would be 67, 80, 85, 40, and 37. That would be for that specific array. That's what we want. Now, I can see here that I'm adding 2, 1, and 2 to get to that number. So how can I... Because initially I'm not getting the multiple of 5, so I cannot say, because a way to get the multiple of 5 would be using the mod operator, probably, right? And using the mod operator, I could say if it's equal to 0, then it is a multiple of 5, right? If that value, I'm gonna make that look a little better here. Just give me a sec. Here we go. That's neat. That needs to be equal if okay. If mod 5 equals 0, or not mod 5, but if the number in the array, it's what I'm trying to say. I started with one idea and ended up with the other, but if that number in that array, just gonna say n of I, mod 5 equals 0, then I know it's a multiple of 5, right? But what happened here? I think this stroke is too thick. I'm gonna kind of take it down a little. Yeah, that's better. But what happened is that I'm not getting, these numbers I'm getting in the array are not modified, so I cannot really say for every number or for every grade in this array of grades, if that grade mod 5 equals 0, then do this operation, right? So I have to apply some sort of conditional on top of these numbers to get it to this number, I guess, and then based on this number, so I will have to modify the numbers in the array before I checked for this. It's basically what I'm trying to say. I know this is a little messy. I know digital whiteboards are not my forte yet, but we're getting better. We live, we learn. I want to see if I can give it a go. I'm trying to think if I should use Jupyter to just start playing with the code, or if I should use like some sort of other other tool. All right, let's see if I can open the localhost. Okay. Okay, so I'm trying to think if I give it a go on a Jupyter notebook or another good tool that people that follow me or people that are watching this video, not necessarily follow me, is this compiler. It's called pythontutor.com, but you can check for, like, you can also debug JavaScript, Java, C, C++, whatever, and it's made for debugging code, right? Because something's not working. But I found it very intuitive in a sense of you can see what's happening behind the scenes and get a feel for what your code is doing. So I just find it interesting personally because it helps me a lot on seeing how my code is working, right? I know you can do this on some IDEs and people know this, and this is, but personally in the learning process is what I'm trying to say. It's always good to see how that's working too, because at the end, it's all about knowing as much as you can about the code you're typing, right? The more you know how that code is going to behave, the more control you have over that code, right? You're not baffling for something that you know it's not, like, or you don't fully understand, right? So this tool is very helpful. Sometimes, like, if I want to see how something's working specifically, I run it here instead of a Jupyter notebook or whatever, but I'm gonna try to give it a go here. And Python 3.11, okay, and then just see how that works, right? So I'm just gonna go ahead and copy the name of the function here. I'm gonna pass a few grades, maybe this one's right here, and work on top of those grades on dot. I'm just trying to grading students. I do this before because once I get into the groove of things, I don't like to come back and have to think about the testing again, right? 73, 67, 38, 33. 78, 67, 38, 33. Those are the numbers, I believe, right? I need a space here. 78, 67, 73, 67, 38, 33. What happening? 73. Jesus, I keep getting confused. 73, 67, 38, 33. All right. Okay. So I said that I'm probably gonna need a new list. Because I'm trying to think. You could probably use list comprehension and do all that, but again, that's outside of my comfort zone right now. And if I have to make a second version of the function to get there, I will do it happily. But for now, let's just say new grades, and that's gonna be a list, right? Also, new grades, I'm gonna say, do I need to, so first, second, so I'm gonna iterate, right? Iterate over for grades, or for grade in grades. Grades is already a list, so it's editable, so we don't have to worry about going through their indexes or anything. So I'm trying to think, because here we were adding 2 and 1, 2 and 1. Because if it's greater, if the sum I have to make it's greater than 2, then it's not gonna pass, which is the case of 37. It's less than 38, so it's not gonna work. 67, it's equal or greater than 3, so it's not gonna work. So maybe this is very naive, and that's okay, right? That's part of the learning process. I could say first, referring as the first grade, it's going to be equal to grade plus 1. I'm going to add 1 here, and then I'm going to say second, and then I'm going to add 2 to this grade, right? Because it's going to be either what I'm trying to do here, and I guess I should explain myself. I'm going to try to bring this numbers to this number, so I can apply the conditional, right? That's the approach I'm thinking, right? It might be a very naive and long approach and not flexible, but as long as I can get the solution by myself first, then I can go into fixing and improving that code, right? And that's, again, I'm gonna say this for a reason multiple times. That's part of the learning process. Everyone learns in a different way. I figure that's the way I learn. As long as I can go through the problem with one solution, then I can learn how to make it better, right? So adding 1 or 2 to it would give me the number I need to compare with 5, which is mod 5, basically the remainder after dividing by 5. If it's equal to 0, then we know it's multiple of 5. So that's why I have first and second grade, saying I need to check. So we also know that we're not going to evaluate any value that is less than 38. So that's another conditional we have to think about, right? I guess I could this is becoming a little tedious here, but values only greater or equal to 38 is what we need. Everything under that we don't need, right? That's what I'm thinking. So every value that is greater or equal to 38, it's going to be your first condition, and then we can apply the second condition, which is that the value has to be a multiple of 5, right? So we have two conditionals that we can apply, or we should apply. First, we filter in our lower bound, meaning every value that is not greater or equal to 38, we're not going to even consider doing this or doing this, because it's going to be a failing value, like in this case 37. If it is then greater than 38 or equal, we apply this, and then we apply the second conditional, which is this one. That makes some sense, right? So let's go ahead and see that. If the grade for grading grades first and second, if the grade is greater or equal to 38, if the grade is greater or equal to 38, n first, which is that grade, right? That grade plus 1. If that grade plus 1, I guess we could add, I could add an example here in this test case. So let's say 84, right? 84 is one number away from being a multiple of 5, which is 85. So it's greater than or equal to 38, and plus 1 mod, I would say mod 5 equals 0. But also I could say n, no, if the grade first, and I could say or, right? The grade is, because I have two values I need to check. So it's either this side is true, either the value is greater than or equal to 38 and plus 1 mod 5 equals 0, or the grade is greater or equal to 38, and I'm just gonna copy this thing right here. I hope this is not confusing. And second, so the value plus 2, which is the case of 73, right? Where 73 plus 2 mod 5 equals 0, because 75 mod 5 equals 0, yeah. Same thing for 70, yeah. So yeah, basically 73, 3, same things. Basically every value ending in 5, what we said, 55, 0, okay. Just kind of double checking that I'm not operating on the base of something that's not existent. If the grade is greater than 38 and the same grade plus 1, which is first, it's mod 5 equals 0, or that grade plus 2, one of those, we can say that the problem is now that I clear up the value, but now this is going to be a little redundant here maybe, because now I need to append whatever value comes after these conditionals, I need to append it to this list, right? But what happened is that I'm using a double conditional because I'm trying to be slick and save some space, but it's becoming really verbose. I'm gonna have to be redundant, at least for this naive approach, and say that to filter between these two, right? Because I say, for instance, and I'll put it here so I can explain myself. If first mod 5 equals 0, so if the first value is the one that's equal 0, then I'm gonna go ahead and append that value to this list. And I'm copying this because I don't have autocomplete and kind of tedious. But dot append first, because I know that's the value that's that. If not, then I'm gonna say same thing but for second, right? If second, if it's not the first one, is if it's not plus 1, it's plus 2, right? Then go ahead and append that to there. Okay, so let's say our first part here is done, right? We did this, we checked I kind of said that I was gonna do this first and then this second, but in the code it made more sense just to go for this, where I can check for all the values all at once. Because another thing is that another thing is that 67, and this is going to be interesting. 67, it's greater or equal, it's greater than 38. But 67 plus 1, it's not mod 5 equal to 0, or plus 2 because it's 69. So it's going to shortcut automatically to whatever I put here now, which is going to be so the value, it's either that or is not. I don't think I need another conditional, so for now, no. If else, yeah, for now I'm just gonna say else. Just go ahead and append the actual grade, right? So what I'm saying is, like, if this grade, I know this code's a little confusing. It's not the best code, but also, like, it's an approach. If it solves the problem, it could work, right? So if this grade in grade, so if 73, well, let's do 67. If 67, I have 67, which is the actual grade, and then I have 68 and 69. So I have 67, 68, and 69, because I'm creating these two values out of it. 67 is greater than 38, but 68 is not equal 0 when we do this operation, and 69 either, right? So now we just say, okay, that is my my little pen, very low. Okay, so where was I? Okay, so nor 67, 68 or 69 passes this condition, so I'm just gonna go ahead and append that grade, right? And that should be it, right? The values are greater, so we're in this condition here, we're saying everything that's under that, don't even look at it. If it's greater than that, it has to be plus 1 or plus 2, because 3, it's not, right? It specified here by the problem. It's less than 3. So next multiple of 5 is less than 3. So less, not equal 3. We saw that here in this example, that 57 is 3 or higher. So we're basically adding 1 and 2, and if it passes that condition, then we grab one of those two. Here, this is very redundant, and I'm sure there's gonna be like 1,000 ways to do this, but for now I'm gonna go with that. Let's visualize this execution, because this is actually the cool part I wanted to show to people that are learning in the same path I am as a beginner, and just trying to have resources that would help you get things in a different way, right? And this is why it's cool, right? We create the function, it goes ahead and call the function with the parameters we pass. These are the parameters. We can see it's a list of grades. It proceeds, it tells you right here, this is the line that just executed. You can see here the little legend, and the next line to execute. So we know that executed and created our arrays with the grades we defined at the bottom. Now it's about to create the new list, right? So there it is, new grades, empty list. So it's going to iterate for every grade in grades. So 73 is, as we can see right here, is the first grade. Now it should take that grade and create a new one. Says first 74, second 75, right? Perfect. Now we're gonna say, hey, if the grade is greater than 38, greater or equal, which it is, and the first value, which is 74, mod 5 equals 0, which is not. But then we say, or the grade is greater than 30, greater or equal than 38, which it is, and second mod 5 equals 0, which 75 residual 5, it's a multiple 5 basically. Here's where I am a little confused. That passes to the next level. So with first, so we know it's not first, so we know it's second. Then we go ahead and append second to the new list. Perfect. Oh, I see a problem. I didn't change that. I left it at first. Okay. I was like, what happened? That's what happened when you copy and paste, and that's where box and stuff like that gets introduced. That's bothering me. But anyways, let's go ahead and jump to where we were. 73, 74, 75. We know 75 is the one, and that's why I'm being a little redundant here. Because after my numbers pass this condition, there's no way I know which one is, and I should. There's got to be a way, and I probably obviously don't know it, but there's got to be a way where I can just take the value based on which one passed the condition. But here I'm saying again, was the first one or was the second one? Was it the first value? No. Was it the second value? Yes. So it says, so go ahead. The red dot is saying go ahead, and or the red arrow, no dot, and append that second value. So we have our new list with our round up value. Now let's see what happened with 67. For grading grades, 67, 68, and 69. The grade is greater than 38, but it's not, nor the second, so it goes ahead and append the 67. Perfect. So far so good. We're gonna do a next pass over 38. 38 should return 40 because 40 is a multiple of 5. We know it's not the first one, so it's the second one, so it goes ahead and adds that to it. Perfect. This is cool. I hope you guys are looking at this and see how you can see your code, and like it's really cool how you can see everything changing here. And it's, I mean, for people that didn't start it with languages more low level like C and C++ and so on, right? These kind of tools are very intuitive because you can actually see how everything it's laying out for you in the back in the back end, right? So I believe, yeah, 33, 84 should be 85. I believe the solution can work. Then after that, oh, okay. I forgot to return the this list right here. Modify. I forgot to return that. So we know that how that's gonna go. So we can always also come here and drag everything, and it will do everything for us. And then it goes ahead, return value, and just points back. So we can see here, it's just pointing back to that list because that is our answer right there, our list. Let's go ahead and give this code a go. Now this code is too long. I'm not gonna go ahead and try to write it down again over there. I hope if I paste it works, because we implemented that solution ourselves, so we know that somehow it's gonna work. I'm just gonna go ahead and paste it here. Return, make sure my what's it called, my indentations are right. And I'm just gonna run the code for the first time and see. Okay, that passes the test case. Four students. Okay, and then the items 67, 40, and 33. Okay, that's exactly the one we were using, so we know that's gonna work. So let's go ahead and submit this. I think I'm confident with that. I mean, at least for a naive approach, it might not be the best approach, and that's where the next step in this process always comes, and it's me trying to improve what I'm doing, right? So let's go ahead and submit the code. Let's see. Wow, that was quick. They all pass. Fantastic. You have earned 10 points. Beautiful. Awesome. Okay. Whoa, that was cool. Nice. I feel proud of that. I think we did a good job there. But now I know that that was not the best approach right now. I know that I'm being redundant here. I know that there are things that I'm gonna have to improve. But again, we implemented a solution by ourselves, and even if it's not the best solution, we completed the whole journey. Now we go and improve from that, okay? At least that's how I like to learn, right? So what I'm going to do is, and I've showed this before, is I'm going to instead of me going here to submit discussions, instead of me going here and seeing other solutions that people post and try to improve it based on other people's solution, upper Mandosio divided times 5, upper grade ideas, grade IDX, grade equal 38. See, that's, some people are really sleek on their solutions. Interesting. Huh. I was looking at that one because it's Python. This Java code is gonna definitely be more longer. But instead of me doing that, I just like to go to where is it? Here we go. I just like to go through my AI. I use Claude. I think it's pretty good, and I have this little chat that I keep with Claude. If you've been following me, or if you've been seeing the other previous videos, or if this is your first video, this is how I normally do things. I just come here and say, hey, basically, I'm gonna paste this here since I have it. But basically, that's the code. It's just too long here, I guess, but that's the code, and I'm gonna basically just say, hey, you know, what is I can already say that the time complexity of this is big O of n because I'm going through the whole array. And these are just older problems, but what I go and say is I went too far up, I guess. Okay, I think this is too big here and I can't see the screen, so sorry about that. I'm just trying to find the prompt that where I say for program program attach I have the following algorithm. Oh, okay, I guess. Okay. Okay. What is the actual time complexity and how can I improve on an interview setting? Yeah, that's basically what I do is, instead of me going again and going back to the solution tab, I just come here, give it a little context. I could go ahead and screenshot this. Honestly, the model doesn't need the whole problem to be described. These things obviously are optimized for that. But I'm just basically saying, hey, for this problem, how can I improve it for an interview setting, right? And it would normally tell me the things I can make better, if my approach is good or not, or so so forth, right? So that's the problem. Okay. And yeah, for that programming problem in the image attached, I have the following algorithm. I could say I want to analyze it and which actually talk about how could I improve the for an interview setting. So another thing is like the reason I ask for time complexity is because I try to like understand time complexity. Like I'm saying it's big O of n because I go through the array one time. Space complexity, it's also it's actual constant time because I'm just creating one extra array and appending items to it. But that could be wrong too. So, but again, let's see what AI has to say, and we'll learn from that. And if it offers a better approach, I'll try to learn everything and see what actually happens behind. I already see a way shorter solution for this. So yeah, it's actually it feels like, you know, asking AI to roast your code, basically, you know, and that's good. You learn from that as long as you know and understand what you're doing, right? I won't come here and ask AI how to solve it first without me understanding, right? I try to have at least one approach. And that might change when I start facing like medium or hard problems, right? But again, it's the whole point. It's to understand what we're doing. That is the whole point. Time complexity O(n), where n is the number of grades. The function iterates through each grade once, performing constant time operations for each grade. Space complexity. Yeah, I thought it was constant, but no, I'm actually appending a new list which is created, which is in the worst case will be the same size as the input list. So there's that. While the time complexity is optimal for this problem, as we need to process each grade at least once, we can improve the code's readability, efficiency, and robustness, and here's an improved version again. That is, to me, good news, right? Because I have something that is optimal for the problem, right? I'm not creating a solution that it's n squared, right? I'm creating a solution that it's optimal for the problem. Like you can definitely solve the problem for it, but the structure of the code could be better. The code could be more robust, could be more efficient, it could be more, in this case, Pythonic or readable for a code base, right? A bigger code base. And here we go. Let's go ahead and read this first before. Simplicity, the logic, okay. Helper function, we abstracted the rounding logic into a separate function, improving readability. List comprehension, I knew list comprehension was going to be an option, but obviously, like, I thought it was going to be outside of my comfort zone. Mathematical approach, it says instead of checking the next two numbers, we calculate the next multiple of 5 directly, which is more elegant and efficient. Oh, well, there you go. Single patch, we only iterate through it on while maintaining in time. In place modification, if memory is a concern, you can modify the input list in place instead of creating a new one, reducing display complexity to 1. Improve validation, error handling, testing, type space, so trade-off between the core implementation. Those are things to keep in mind in real world, like in real case scenarios, right? Additional point to mention in an interview, yeah. Okay, let's check this solution. So, grading students create a different function to round the grade. So it takes the grade. If the grade is less than 38, then it's just return it. Then it says next multiple. It's going to be the grade plus 4 divided by 5 times 5. Return next multiple. If next multiple minus the grade, minus 3, else the grade. Return, round the grade, round grade. Okay. Okay, this is returning a list comprehension of round grade of grades for grade in grades. See, that's list comprehensions. It's like so like for this and this and this. I don't know. I guess I still a beginner at heart, so I'm definitely I gotta get used to it. This next multiple. This is an interesting way to calculate that. I don't think I would think about it. I definitely thought about the mod operator. But this is way different from my code, so yeah, time complexity of my code is it's okay, but it's not it's optimal, but it's not necessarily like the code is totally different. Next multiple. I want to know I want to know, because if I need to see this actually. I need to see this operation. Actually, I just need to know this. The grade plus 4 floor division times 5. Let's just use like let's just use this like a quick calculator here, right? Let's use one of these inputs. So let's do 73, right? Let's do 73. So let's say 73 plus 4. Now I gotta put that into, you know, an order of operations and so forth. So 73 plus 4 divide it by 5 times 5 equals 77. Okay, I see what I'm doing. I gotta close this here too, then close this here too. So 73 plus 4 by 5 times 5. You can also do this separately. So 15.4. So 15.4 times 5. I don't understand. I don't understand here. Okay, I know it's using the double, which in Python is different. So for the second attempt, or the, let's say the improved version of the function, this is the first attempt, and let's say it wasn't the most optimal one. But I was trying to figure out, once I was checking the optimization here, how to get the next multiple. And I was a little confused by this little mathematical trick here, right? I'm like, wait a second, like I can't understand what's happening, but also I really didn't know. So obviously I went a little deeper and figure something out. So apparently there's this trick where to find any multiple, at least in let's say discrete mathematics or computer science, we can use the floor division for any number, and there's a little formula that basically goes like x n minus 1 times n, and that's going to be equal to the multiplier that we want to find. So In this case, let's say for instance using the same example with the formula to find the multiplier. Let's say for instance 78, we're going to take 78, which is x, right? The multiplier we are looking for is 5, so we're going to say n minus 1, which would be 5 minus 1, which is 4. Actually it's plus, we have to do an addition. I just remember actually how it was. And then you so floor divide that. So this is wrong here too. You divide that by n and then multiply that by n. And that should be the multiplier. So we're looking multiplier of 5. We have 78 starting from here. So we add 4, which is n minus 1. It's actually minus because x plus, that's the formula right there. Sorry about that, I was just struggling a little bit with it. But x plus n minus 1, floor division of n times n should be the multiplier. Okay, so that's exactly what it's going on here. As we can see, the grade we're getting in the grades here, it's what is giving us plus 4, which is n minus 1, which is 5 minus 1 for the floor division 5 times 5. Sounds like a mouthful, but that's what that is. So 78, which is the number we're looking for, plus 4, which is n minus 1. We divide that by n, which is 5 in this case, and then we multiply that by 5. So let's add a couple parentheses here, so we go by order of operations. And that should be equal to 80 in our case, which it is. So that's how that works. So with that trick under your sleeve, we can now have a different, we can now go ahead and implement this right here, this solution. Again, the idea is to implement one ourselves, which is, let's say, a naive approach, which is what we use here. And it worked. We passed all the test cases. However, even though this is a big O of n implementation, we're using also n spaces in our space complexity, because we're creating a new array. It could potentially be the same size of the initial array, in case that all the grades are round or roundables, right? Or I guess you can round them up. So yeah, I just had to do a little digging in this thing, because I was like, hey, how does that even happen? Like, how can you just come up with that and put it in there and be like, yeah, this is how you solve this problem? Like, where the heck this thing comes from? But I guess you can do that for any multiplier. It's a trick that it's been used in computer science for quite a long time. Again, some things that it's important to learn and have as part of the process we're doing right now. So here's the implementation. with that new one. The idea is that I could go ahead. So for the second part of it, we're creating a new function here to round up the value. Then we're calling that function in a list comprehension with the grade that we already round up, and saying, round every grade for grade in this list. And it's doing it in place, so it's not really using a new array. So space complexity also improves. Here, the return, it's also very Pythonic, I would say, in the sense of like next multiple, if next multiple minus grade less than 3, else grade. So it's using an if and else statement. Excuse me, it's using an if and else statement in the return function, which is just another way of doing the if else then return. It's just Pythonic, I guess. So I'll try to implement that function as the second trial, the second implementation here. The idea is that it understanding everything that's behind it, and if that works, then we're good to go. So we're saying that the first step, we're going to create a rounding function. Get something in my eye. So we're saying the function that it's going to be round grade, takes the grade, say if the grade is greater than 38, then we're gonna say next multiplier is gonna be equal to that slick function where we say grade plus 4 for division of 5 times 5. That's what grade is. And then we have the next multiplier, and then we say the return, which is as return. Well, I guess if grade is less than 38, simply return grade. I think that's the way. And then from there we say this goes here. Then we say next multiplier is equal by the grade times plus 4 . Then we return grade minus that returning part right there. So next multiple, not multiplier, but return the next multiple if the next multiple minus the grade is less than 3. So we're basically saying if 80 minus 78 in this case, right? So if 80 minus 78 is less than 3, return the next multiple, which is going to be 80. Else, just go ahead and return 78, which is the condition that was first established. Bless you. Which is the condition that was first established. It's gotta be less than 3. So basically 2 or 1. So that's why that works. That's understandable. Now we can go back. Where is it? Here we go. So return next, not multiplier, it's next multiple. So return next multiple. If next multiple minus grade is less than 3, else grade. So basically saying return. Let's go ahead and use 73 here in the example. So we know the next multiple, so 73 plus 4, it's going to be 77, and we can do that here. 77 divided by 5, it's going to be 15. Instead of 15.4, we're using floor division, so 15, I'm going to do it right here, 15 times 5, it's going to be 75, right? So that's our next multiple of 73. So return 75 if 75 minus the grade, which is 73, is less than 3. What is the result? 2. So it is less than 3, so that number subsequently becomes round up. And then we need to, outside our function, return our main function that's just going to return a list comprehension return. We call the function here round grade with grade. For grade and grades. And that honestly should be it. Pretty clever way to approach the function round grade for grading grades. That honestly should also work. Let's give it a go. And yeah, evidently that's a very, very cool approach. I have to say I definitely learn a lot in this problem. Going from my first iteration to this iteration, I had to do a little research. I also paused the video when I had dinner and everything, but when I came down, I really just tried to understand what was going on here. And then obviously everything else is just knowing a little more Pythonic code, which is this case right here, and also this case right here, where I would have probably used the if-else statement and then return. You can just remember you can do that, but you have to see it to remember it. So there's that. Let's go ahead and submit this code. Make sure everything works. And definitely I think it's gonna do. We're waiting. We have last test case that is taking forever. And congratulations. Here we go. So, grading students problem solve from a naive iteration to a more interview material implementation. So that is for today. Hope to see you in the next one.